Now we are going to explain the PN junction under reverse bias. Now you can look at the block diagram now. The P region, holes are the majority charge carriers, and in the N region the electrons are the majority charge carriers. And when there is no external battery connected, that means when the PN junction is in the unbiased condition itself, there is an internal potential barrier, and the barrier voltage is denoted with the symbol VB, and that is 0.7 volt for silicon, and for germanium it is 0.2 volts to 0.3 volt. Okay. Now when is a diode said to be reverse biased? When the P region is connected to the negative and the N region is connected to the positive of an external battery, then the PN junction or the diode is said to be reverse biased. Okay. Now you look at the polarities of the VB and V applied. Okay, students. So this is the applied voltage and this is the barrier potential. The N side of the junction is having a positive potential. Similarly, the N side of the junction is connected to the positive potential of an external battery. The P side of the junction is having a negative potential across the junction, and the same P region is also connected to the negative terminal of the applied voltage. That means V applied and VB both are in the same direction. Okay, so I am going to summarize the points now. So what is the first point now? The P region is connected to the negative potential or negative terminal of the external battery, and N region is connected to the positive of the external battery. Okay, students. Now the second point here is V applied and VB are in same direction. They are in the same direction. As a result, what will be the net potential difference across the junction? Therefore, the net potential difference across the junction. So across the PN junction, the net potential V net is equal to what? VB plus V applied. Okay, students. As a result, you see that this is the unbiased PN junction. This is a height, barrier height VB. Suppose if you apply an additional voltage, means what will happen to the barrier height? You will see here the barrier height increases. Okay, the barrier height will increase like this. So this one is V applied. Okay, after applying a external voltage. So as a result of this, the barrier height increases. When the barrier height increases means what will happen to the width of the barrier? This width also will reduce or increase. It will increase. Okay, students. Now why it will increase? For that another explanation is required. For that another set of points I am going to explain. Now look at the terminals of the battery. The positive terminal of the battery, that is applied voltage, is connected to the N region. In the N region, who are the majority charge carriers? Namely the electrons. So these electrons will be attracted. These electrons will be attracted towards the positive terminal of the battery, and the positively charged holes will be attracted towards the negative terminal of the battery. Because of this, what is going to happen? This time the holes will be moving away from the junction, and the free electrons will also move away from the junction. This is very important point. So the holes and the electrons move away from the junction. But in opposite direction. Is it not? They move away from the junction. Here also in opposite directions only. Because of this, there is no recombination. Okay, there is no recombination. So there is no recombination. As a result, what is going to happen, you know, here additional ions will be formed. Additional positive and negative ions will be formed, okay, on both sides of the junction. So, on the N region of the junction, positive ions number will increase. Similarly, on the P region of the junction, the negative ions will increase. So that now you can see the new width of the barrier, okay. So you can see that as a result, what will happen? There is no recombination, okay. The barrier width, okay, the barrier width increases, okay. Why the barrier width is increasing? Because the number of ions, formation of ions will be more, okay, than in the previous case. Therefore, the barrier width increases. What is the barrier width? Is a measurement of electrical resistance, is it not? So, here the electrical resistance increases. When the electrical resistance increases means what will happen? The current cannot easily flow, is it not? See, in this case, since the holes and electrons are moving in opposite directions away from the junction, here the diffusion current decreases because the, see here, the applied voltage V applied will suppress, okay, it will suppress the diffusion of a majority charge carriers, okay, it will suppress the diffusion, okay, the diffusion of majority charge carriers. So when the majority charge carriers are suppressed means diffusion current, hence diffusion current is reduced, or diffusion current will be nearly equal to 0, nearly equal to 0 or very very less only, okay students, very less current or nearly equal to 0 also we can say. So I am going to summarize the another set of points. Up to this have you understood, my dear students? Okay, so what are all the important points? When is a diode said to be reverse biased? When the P region is connected to the negative terminal and N region is connected to the positive terminal of an external battery, or V applied and B must be in the same direction, then also the PN junction or the diode is said to be reverse biased. Now what is the net potential difference across the junction in this case? It is equal to the sum of the barrier potential and the applied voltage, is it not? So as a result, what happens? The barrier height increases. You can see this graphical representation. The barrier height increases. Okay. Now the holes and electrons move away from the junction in opposite directions. So in this case, the holes are attracted towards the negative potential of the battery and the electrons from the N region are attracted towards the positive terminal of the external battery. So they move away from the junction in opposite directions. As a result, there can be no recombination of the holes and electrons in this case. And as a result, the barrier width also increases. So consequently, the resistance increases. Now the applied voltage suppresses, okay, suppresses the diffusion of the majority charge carriers. As a result, the diffusion current in this case will be nearly equal to 0 or very very less. Okay students, now I am going to explain the next sequence of points. So my dear students, there is no current due to the diffusion of the majority charge carriers. However, there will be a few microampere of current, very low current due to the flow of minority charge carriers. You tell me now, in the P region, who are the minority charge carriers? The electrons. And these electrons being negatively charged, they will be attracted, okay, towards the positive applied to the N region. And the minority charge carriers in the N region, namely the holes, they will be attracted towards the negative potential applied to the P region. As a result, now minority charge carriers will drift in a direction opposite to that of the junction. Okay students, so this is the next point. The minority charge carriers, So what are the minority charge carriers in the P region are the electrons, and the minority carriers in the N region are the holes. Okay, students. So the minority charge carriers drift across the junction. As a result, a very low current, a few microampere current will flow, will flow. Now this current is going to flow from which direction to which direction? That is from N towards the P region, from the N region towards the P region, because conventional current is the flow of holes, is it not? So the minority holes in the N region will flow towards the P region. That is why a few microampere current, and this is called as the drift current. Diffusion current already nearly equal to 0 or very less, is it not? So suppose if you take means, see the drift current is from the N region to the P region. So this is the diffusion current, means this will be the drift current. Suppose if this is the diffusion current and this is the drift current, means the diffusion current will be less than the drift current. Now both in forward bias as well as the reverse bias condition, the drift current's magnitude will be the same. Okay, in the forward bias condition, the diffusion current's magnitude will be greater than that of this drift current. But in this case also, the drift current is not going to change much by the applied electric field. So it remains the same almost in forward bias as well as the reverse bias condition. Only who is changing according to the biasing condition? The diffusion current only is changing. Understand, students? So the net current is now the drift current minus the diffusion current, and the drift current is in which direction? You see, it is from the N region to the P region, and it is of the order of a few microamperes because it depends on the minority charge carriers. Okay, students. Secondly, this drift current, is independent of the applied voltage. This drift current is independent of the applied voltage, but it depends on one factor. Okay, students, it depends on what factor? Means on the concentration of the minority carriers. Concentration, concentration of minority charge carriers. So, which again depends on another factor that is called as the temperature of the junction. Okay, students, temperature of the junction. So, if the temperature of the junction is increased, means more number of covalent bonds will break. As a result, what will happen? This drift current also may increase. But it is independent of the applied voltage. It depends only on the concentration of the minority charge carriers, which again depends on the junction temperature. Now under normal reverse biasing conditions, what will happen? The diffusion current will be very minimum, and the drift current due to the minority charge carriers will be of the order of a few microampere. This current is in the reverse direction, and hence this current is called as the drift current is called as reverse current. Okay, students, so why there is a reverse current? Why current is permitted to flow here? Because of the flow of the minority charge carriers in the opposite direction to that of the majority carriers. Therefore, it is called as reverse current. And it is also in some book, it is denoted as a reverse saturation current also. So, in some textbooks, they have mentioned this reverse current as reverse saturation current. Okay, students, why? Because the current has attained a constant value and it is independent of the applied voltage, is it not? Therefore, it can also be called as reverse saturation current, I saturation. But normally in textbooks it is mentioned as I reverse only. But in some textbooks they have mentioned the same as reverse saturation current. So, from the applied voltage is varied from 0 then to 1 volt, 2 volt, 3 volt, like that in steps, okay, in multiples of volt. If you increase the reverse bias voltage, the current will be independent of the applied voltage and it will be constant up to a certain maximum called breakdown voltage. Okay, students, up to breakdown voltage. Okay, up to a voltage, critical voltage called as the breakdown voltage. From this breakdown voltage and beyond, okay, from this breakdown voltage and beyond this, the current abruptly or rapidly increases. That we are going to see in the subsequent topics only. Okay, students. So till you apply a breakdown voltage up to a certain critical voltage called breakdown voltage, the reverse current is constant and it is independent of the applied voltage. That is why it is called reverse saturation current and it is of the order of a few microamperes only. Have you all understood, students? So next we are going to repeat the same topic in terms of the dependence of the applied voltage and the current flowing through the diode. That is called as voltage versus current, VI characteristics of a diode. That is the next topic. Until then, bye.